Hey everyone. So today we're going to continue our discussion of equations by looking at something called literal equations. And we're going to continue to use the same strategies that we've been using to solve equations. But what's going to look a little different in these questions, and I'm going to go ahead and go over to one of them right now so you can start to see what a literal equation looks like, is we're going to have multiple variables in these equations. Um, so essentially, when we see a question like this, we're going to see two things. First, we're going to see the actual question, the actual equation. And in this case, that equation says ax plus by equals c. And we're going to be told what variable we should solve that equation for. And when we're told what variable to solve that equation for, essentially what they're telling us is what needs to go in the middle of our onion. So if I look right now at this equation, ax plus by equals c, since it's asking me to solve for y, right in the middle of my onion, I need to circle that y. That's going to go right in the middle of my onion. And then after that, I'm going to build the onion in the exact same way that I have before. So what am I doing to that y? I'm multiplying by b, according to PEMDAS, and then I'm adding an ax to it. And all I need to do at this point, even though they're letters, is the exact same things I would have done if this was an equation with a bunch of numbers in it. I've got to peel away those layers of the onion. So the first outside layer of this onion says plus ax. And the way that I get rid of plus ax is minus ax. And just like in equations that we've done in the past, if I have to subtract something from the left side, I have to also do it on the right side of this equation. So as I'm looking at this right now, ax minus ax is going to cancel out, and I'm going to be left with by equals. And on the right-hand side of my equation, all I see is c minus ax. And since those are not like terms, the best I can do is write c minus ax. Essentially, all I'm doing is copying exactly what's already there. All right, next step. I have my b and my y. Same idea with my onion here. That b is multiplying by the y right now. And so to get rid of that multiplication, I've got to use division. If I want to get y by itself, I'm going to divide by b on both sides. And I'm going to end up with y equals c minus ax over b. And that is how you solve a literal equation. It's the same two steps that we would normally do in a two-step equation. This first step we did subtraction, so that's SPO. And in the second step we did division, which is DPO, division property of equality. And in the end, we've got a new equation that is now solved for the variable we were trying to solve for, which was y. So here's another question, and I'd like you to try this one. Notice that we're solving for t, which means that t has to be in the middle of our onion. Go for it. All right, so let's see if you get it, if you got it right. I'm going to circle t, and what am I doing to that t? I'm multiplying by 5, and then I'm subtracting 2r from it. The outer layer of that onion is minus 2r, and I get rid of minus 2r with a plus 2r. And if I do it on the left, I have to do it to the right. I'm going to bring down the 5t, and on the right side, I have 25 plus 2r. 25 plus 2r. Well, 25 plus 2r, those are not like terms, so the best I can do is just write 25 plus 2r. Second step, the 5 and the t are being multiplied, so I'm going to divide to get t by itself. We will divide by 5 in this case, and we will get t equals 25 plus 2r over 5. If you want to write this a little bit differently, it is possible to simplify this fraction that has two numerators and one denominator. We could think about this as 25 over 5 plus 2r over 5. We're essentially writing those two fractions separately. And that could be then simplified to 25 divided by 5 is 5 plus 2r over 5. I'm really okay with any of those answers. You more than likely stopped here if you got it right, and that works for me. But this is also a correct answer down here. If we want to go ahead and finish simplifying, that will work. Let's look at another example. We're being asked to solve in this example for n. This question looks a little bit more like the multi-step equations that we've been doing. And so I want you to think about what your possible first step could be here. You actually have two options. So what two things could I start with here? Okay, so let's go ahead and solve it both ways. Option one is to go ahead and distribute this s, and we get a equals s minus d n s. And then we can build our onion. So we're starting with n. N is being multiplied by d and s at the same time, so we can make one onion layer out of that. And then we've got this s over here that we've got to get rid of. So the first thing I want to do is get rid of this s, that s right there. And because it's a positive s, I get rid of it with a minus s. Remember that this minus sign right here applies to the dns. It doesn't apply to the original s over here. That one's positive, so we've got to subtract. I'm going to get a minus s equals negative dns. Now to get n by itself, I have to get rid of negative d and s. And I can do that by dividing by negative ds on both sides. And ultimately, that's going to give me n equals a minus s over negative ds. And that will be fine as an answer. But let's look at our other option. What if we instead, so let's go back and get rid of those. What if instead we started to see this as an onion from the very beginning with n, dn, 1, and then this s around the outside? If that's the way you saw this, then the first thing you did instead of distributing might be to divide both sides by s. And we get a over s equals 1 minus dn. Then we could subtract 1 from both sides, and we would get a over s minus 1 equals negative dn. And finally, we could divide everything here by negative d. But you see this answer that we get over here for n is a compound fraction. And we don't really like leaving answers in this form of a compound fraction. So what I'm going to recommend for us is that in the event that we see a question like this, it might be a little bit easier for you to go ahead and distribute first and choose this first method instead of starting with division and ending up with a compound fraction. So I want to give you a chance to see, to try a question like this yourself, and go for it. All right, so let's chat. First thing that we should do, as we saw in that last example, is we can distribute this p, and we're going to get p plus prt equals a. And now we can build our onion around t. That's what we're looking for. So we're going to go t, and t is being multiplied by p and r at the same time, so they can go in the same onion loop. And then we're adding p. So what step should go first? All right, so we're going to get rid of p with a minus p, and if I do it on the right, I have to do it on the left. We're going to get a minus p equals prt. And now to get t by itself, since we're multiplying by pr, we have to divide by pr. And ultimately, we're going to get that t equals a minus p over pr. So literal equations, can sometimes be a little bit tricky for students to kind of get a hold of. So if tonight's video went too quickly for you, or you're not really sure what happened, that's all right. We're going to go ahead and continue to work on this in class tomorrow. We will get into some groups, and if you need some extra support, I will be there to help you. And if this made perfect sense, then good for you. You will be like last time, you'll be working kind of in small groups and independently to kind of prove that you know what's going on. So if you have any questions, let me know, and I'll see you all tomorrow. Bye.